Hello viewers, today we'll see about coordinate geometry. A pair of points on a plane is called the coordinates, and the x coordinate is called abscissa and y is called ordinate. And if you see there is a line AB, if you want to find the distance between line AB by extending them at a point where it meets, if you see it's a right angle, then we can find the hypotenuse by sum of squares of other two sides. So if you say the points x1, x2, y1, y2 forms the coordinate x1, y1 and x2, y2. So we can definitely find the distance between A and B by taking the square of the other two sides. So x2 minus x1 whole square plus y2 minus y1 whole square. So that way we get the longest side, the distance hypotenuse. So x1 and x2 are on the x-axis. So the distance between A and C is x2 minus x1, and same way distance between B and C is y2 minus y1. And also we know the positive x-axis, y-axis, negative side of x and the negative part of y. And the four quadrants we are familiar: first quadrant, second, third and fourth quadrant. In fourth quadrant, y is negative value and x is positive. So with all this, we will get to know the distance formulae. AC square equal to AB square plus BC square. Sum of squares of other two sides. So which can be written as AC square equal to AB square plus BC square. Sum of square of other two sides, which can be further written as AC equal to square root of AB square plus BC square. So we know the difference on the opposite and adjacent sides. So by squaring up them, we get the formula of distance. X2 minus x1 whole square plus y2 minus y1 whole square. So the difference between the x points gives you the x2 minus x1 and the difference between the 2 points on y gives y2 minus y1. So with this we can solve the exercise 6a. Question 1. Find the distance between the points. Let's assume these 2 points as AB. So with the distance formula, we can solve this entire exercise. So x2 minus x1, that's going to be 15 minus 9 whole square. So these are the 2 points on x, 9 and 15. So 15 minus 9 whole square plus y coordinates 11 minus 3. So the 2 points on the y-axis. So that's 11 minus 3 whole square. Square root of 15 minus 9 is 6 squared. Plus 11 minus 3 is 8 squared. So we get square root of 36 plus 64. Square root of 100 is 10. So the distance is 10 units. Next, question 2. Find the distance of each of the following points from the origin. So origin is 0, 0. And we got only one point here. Let it be A. A can be on the positive or the negative part. Let's see the point coordinates. That's 5, minus 12. So it's on quadrant 4. So the distance is going to be OA. That is square root of 5 square plus minus 12 whole square. So that gives us square root of 25 plus 144. That's going to be square root of 169. So the distance is going to be 13 units. 13 square is 169. So that's the distance from the origin. Question 3. Find all the possible values of x. And we got 2 points A and B, and the distance is already given as 5 units. So the LHS is already with us. We'll substitute the RHS. 5 minus x, both are x coordinates, whole square, plus 3 minus of minus 1 becomes 3 plus 1, 4. So minus of minus becomes plus 1, whole square, phi equal to 5 minus x whole square is of form a minus b whole square, which is a square minus 2ab plus b square. So 25 plus x square minus 2ab. That's going to be 5 2s are 10, 10x minus 10x. Plus 4 square is 16. So we can square both the sides to remove the square root. LHS is now 25. And RHS is going to be 25 plus 16 minus 10x plus x squared. So 25 on LHS and RHS just goes off. So 0 equal to 16 minus 10x plus x squared. So this is in a form quadratic equation. So we can see product is 16 and sum is minus 10. So 16 is 8 2s are 16, minus 2 minus 8 gives minus 10. So which can be written as x into x minus 2 minus 8 is going to be the other factor, minus 8 equal to 0. So the value of x can be either 2 or 8. Please do not leave any steps. Each step carry marks. Next, question 4. Find all the possible values of y, very similar, and the distance is already given as 10 units. So the distance between A and B is 10 units. But we should see in which quadrant it falls based on the value of y. So LHS is already given. Distance is 10 units. We know the formula of distance. AB equal to 10 minus 2 x coordinates, that is 8 square, which is 64, plus y minus of minus 3, so it becomes plus 3, which we can expand y plus 3 whole square. So y square plus 6y plus 9. Squaring both the sides, we already know the distance, which is mentioned in the question. So 10 squared, that's going to be 100. (64 plus 9), all numerals first, 6y plus y square. So we can just simplify all the numerals to write it in a quadratic equation form. That's going to be y square plus 6y minus 27. So product is 9 threes are 27 and the sum is plus 9 minus 3. So this can be written again as y square plus 9y minus 3y minus 27 equal to 0. So the 3 into minus 3 is minus 27. 3 minus 3 is plus 6. Sum the product of a quadratic equation. This can be written as y into y plus 9. And the other factor is going to be minus 3 into y plus 9 equal to 0. So y can be minus 9. Y can be 3. So it can fall on both the quadrants. Value of y is negative, then it falls on quadrant 4. Next, question 6. If the point A into A is x comma 2 is equidistant from the 2 points are given, B and C. Find the value of x, find the length of AB. So two part of questions. First part is they are equidistant. It has already been mentioned. And we need to find the value of x in point A. So AB is equal to AC because it's equidistant. So by squaring both, AB square is going to be AC square. And we can find AB square and AC square by applying the distant formula, by considering both the points A and B and A and C. So using the distance formula, we can find what is AB square equal and AC square. So that's 8 minus x coordinates of both A and B whole square plus y coordinates minus 2 minus 2. Minus 2 minus 2 whole square equal to AC square. Very similar way we do the RHS also. 2 minus x whole square, x coordinates of A and C in this side, minus 2 again, y coordinates of A and C whole square. So 8 minus x whole square is of form A minus B whole square. So by expanding the formula, A square minus 2AB plus B square, 64 minus 16x plus x square minus 4 whole square is 16 plus 16. Equal to 2 minus x whole square again in A minus B whole square form. So 4 minus 4x plus x square minus 4 whole square is again 16. 16 and 16 goes off both LHS and RHS. X square also goes off from both LHS and RHS. So we get 64 minus 4. We take all the numerals on left hand side and the x values on the right hand side. 16x minus 14x. So 60 equal to 12x. X is going to be 5. So we begin by approaching this by looking at the equidistant and then by applying the distant formula. So now we can apply it to get the value of length of AB. So 8 minus 5 whole square, that's 3 squares, so 9 plus 16. So square root of 25 is 5 units. So second part of the question, length of AB is 5 units. X is also 5, length is also 5 units. Next question 8. Find the point on the x-axis which is equidistant from the points and two set of points are given. So let's assume the point P x comma 0, because it's a point on the x-axis, it's already been mentioned, is equidistant from the two given points. Let's assume those two points as A and B. So a is 2 comma minus 5 and b is minus 2 comma 9. So equidistant, so AP is going to be BP. Squaring both the sides, PA square equal to PB square. So by distance formula, we can write PA coordinates. X coordinates are 2 and x. So 2 minus x whole square plus y coordinates are minus 5 and 0. So minus 5 minus 0 or just minus 5 whole square equal to PB square. So we'll look at the coordinates of P and B. Minus 2 minus x whole square plus 9 minus 0 whole square or just 9 square. So LHS, if you see 2 minus x whole square is of form a minus b whole square. So by expanding the formula, 4 minus 4x plus x square minus 5 whole square is 25. So plus 25. And right hand side, minus 2 minus x can be written as x plus 2 whole square. Both are negative integers. So that's x plus a plus b whole square. So 4 plus 4x plus x square. 9 square is 81 plus 81. So x square and x square goes off. (29) minus 4x. 81 plus 4 is 85 plus 4x. So that's going to be minus 4x is minus 8x equal to 85 minus 29, that's 56. So x is minus 7. So minus 7 comma 0 is the point. P is minus 7 comma 0. Next, question 9. Find the points on the x-axis, each of which is at the distance of 10 units from a point A, 11 comma minus 8. So distance is already given over here, 10 units. So let's assume the point P, x comma 0. So PA square equal to 10 units. So 10 square, that's 100. So 11 minus x whole square plus minus 8 minus 0 whole square, or just minus 8 whole square, equal to 100. So 11 minus x, a minus b whole square, 121, 11 square, 11 2s are minus 22x plus x square plus 64 equal to 100. So now we can write the quadratic equation by simplifying all the constant terms. X square minus 22x plus 85 equal to 0. 85 can be written as minus 17 into minus 5, that is 85, minus 17 plus minus 5, that's minus 22. Product and the sum. So x into x minus 17 minus 5 into x minus 17 equal to 0. So x minus 5 into x minus 17 is 0. 5 into 17 is 85 product. 5 and 17 both are negative integers. When you sum up, it's minus 22. Sum and the product. X can be 17 or 5. So the point is 17, 0 or 5, 0. Next question 13. Find the coordinates of the point equidistant from 3 given points. Let's assume the point to be O, x, y, and it is equidistant from all the 3 points mentioned over here, A, B and C. Meaning OA is equal to OB equal to OC. So OA square, OB square equal to OC square. So let's do OA square first. 5 minus x whole square. All 3 are equidistant. So we can just take one at a time. First we'll get the value of y and then the x. So 5 minus x whole square, that's OA square, x coordinates plus the y coordinates is 3 minus y whole square equal to b. OB square is 5 minus x whole square plus minus 5 minus y whole square. So we'll take these two first. 5 minus x whole square goes off on both the LHS and RHS. So only the y terms are there. 9, it's of form a minus b whole square. So 9 minus 6y plus y square equal to RHS is of form minus 5 minus y, so it's y plus 5 whole square. 25 plus 10y plus y square. So y squared terms goes off here, both LHS and RHS. So we can just take y on one side and the numerals on the other side. That's going to be minus 6 minus 10, so 16, y equal to 16. Y is going to be minus 1. By substituting this value of y in any one of the equation, OB square, we can get the value of x as 3. So coordinates of the point O is 3, minus 1. I believe this is useful. Please do share and subscribe. Thank you.